Here we have a SAT math problem. Okay, let's go to the question. Three consecutive even integers are ordered from smallest to largest. 5 times the first integer is at least 9 more than the sum of the second and third integers. What is the minimum possible value for the second integer? Okay, let me consider an even integer 4. What is the consecutive even integer of 4? That is 6. What is the consecutive even integer of 6? That is 8. Here we have 3 consecutive even integers. Okay, from 4, if I want to get the consecutive even integer 6, what should I do with this 4? I have to add 2 to 4. Now from 6, if I want to get the consecutive even integer 8, what should I do with this 6? The same thing, I have to add 2. So in this way, we can get consecutive even integers. Okay, for the given scenario, I do not know what is the smallest even integer. Let me assume x as the smallest even integer for the given scenario. Then to get the consecutive even integer, we have to add 2 to this x. Then I'm getting x positive 2. From x positive 2, to get the consecutive even integer, I have to add 2 to this one. Then I'm getting x positive 4. Here we have 3 consecutive even integers. In this one, x is the smallest one and x positive 2 is the second integer. According to the question, we have to find minimum possible value for this x positive 2, which is a second integer. Okay, now let's consider this information. 5 times the first integer, that is 5 times the first integer x, we can write 5x. And now let's consider this information. The sum of the second and third integers, that is we have to add this one and this one. Then I'm getting x positive 2 positive x positive 4. Now let's consider this complete statement. 9 more than the sum of the second and third integers. 9 more than means we have to add 9 to the sum of the second and third integers. So we get a positive 9 over here. Okay, now let's consider this complete statement over here. 5 times the first integer is at least 9 more than the sum of the second and third integers. That means the minimum value of 5 times the first integer is 9 more than the sum of the second and third integers. So the minimum value of this 5x is this expression. That is, the value of this 5x can be equal to this one, or the value of 5x has to be greater than this one. So it can be written as an inequality by taking greater than or equal to sign. Okay, in this inequality, we have to get the minimum value of x. Using that minimum value of x, we can get the minimum possible value of this x positive 2, which is the second integer. Okay, now let's get the minimum value of x in this inequality. Okay, 5x greater than or equal to, now we can remove the parentheses. We get x positive 2, positive x positive 4, positive 9. We get 5x greater than or equal to, let's combine the like terms. When I combine x and x, I'm getting 2x. When I combine the three numbers over here, I'm getting positive 15. Let me subtract 2x from both sides. Then I'm getting here 2x negative 2x will cancel out. 3x greater than or equal to 15. Let me take the same inequality over here. Let's divide both sides of this inequality by 3. Then this 3 will cancel out. We get x greater than or equal to 15 divided by 3 is 5. And we know that x is an even integer. And we got the result x is greater than or equal to 5. Since x is an even integer, we have to consider the even integers in this inequality. Then we have x equals to 6, 8, 10, 12. In this way, we can write multiple even integer values for x in this inequality. And we have to consider the minimum value of x, that is 6. Okay, now let's plug in 6 into this one to get the minimum possible value for the second integer. When I plug in 6 for x over here, I'm getting 6 positive 2, that is 8. Therefore, the minimum possible value for the second integer is 8.